Good morning, everyone. Thanks for attending our webinar today on PCI compliance in Amazon Web Services. My name is Gaydosh. I'm the Director of Security Intelligence here at Anitian. I'm a QSA and oversee our PCI practice and have been in the industry for over 15 years. Additionally, with me on the presentation, I have Jordan Wiseman. He's a Senior Security Intelligence Advisor here at Anitian, also a QSA with extensive industry experience. And he and I were the co-authors on a workbook for achieving PCI compliance within AWS that we partnered with Amazon and they published on our behalf, which we'll make sure that you have a link provided. We just published the revised version of the workbook last week to address changes in Amazon Web Service offerings and the compliance of some of them and how they can support compliance, as well as to address some of the changes that occurred with 3.2 version of the DSS. So just briefly about Anitian here, we've got 4 primary practices. They're all built around our mission statement, which is to build great security leaders. Vision path, which is our compliance practices, is where our PCI work comes into play, as well as quite a bit of other regulatory standards. We have our own risk assessment methodology based off NIST 830 that's factored into our risk malpractice. Got an extensive range of capabilities within technical security testing and the Ring Zero practice. And then finally, we have our managed threat intelligence service called Sherlock, which provides capability on-prem as well as in cloud environments such as AWS. So the intent of this presentation, as I said, is really to talk to you about our experience with PCI and Amazon Web Services so that we can help educate you on the most effective ways to leverage what Amazon Web Services brings to the table to achieve PCI compliance. What are some of the potential obstacles and how you can work around those, and some of the caveats, and most importantly, just understanding the various cloud technologies, which are abstracted a little bit, or in some cases quite a bit, from traditional IT technologies, and mapping those to the language in the PCI DSS, since the standard does not really speak in the context of cloud technology nomenclature. And so that's where we see a lot of confusion of trying to understand how some of these different technologies in the cloud actually serve as a capacity to meet PCI compliance. So we're going to go through the AWS services for PCI compliance, those that are the most capable in helping you meet the DSS requirements. We've got a lot of content to go through today, so we'll be moving at a fairly quick pace so that we have time for Q&A at the end for you folks. But we are going to step through each of the 12 DSS requirements plus the applicable appendices to speak to how some of the services could be leveraged for compliance. We're going to talk about reference architectures that we built out. They're denoted in greater detail, of course, in the workbook, as well as with steps on actually how to build them, screenshots and such, but 3 different reference architectures for cardholder data environments within the cloud. Talk about some third-party solutions that exist to help support compliance efforts in AWS, general best practices, and finally Q&A. So feel free to chat in, and we'll address as many of the questions as we have time for at the end of the call. So if we could begin with AWS PCI compliance. So they are validated annually as a level 1 service provider. So that means, of course, that you can leverage their compliance efforts to support your own compliance efforts within AWS. A really important point here is to make sure that you're clear, and this is not unique to AWS, this is for all service provider attestations of compliance, is that just because you're using a compliant service provider does not mean you inherit their compliance status. What it means is that the infrastructure of theirs that is within your assessment scope does not need to be assessed as part of your assessment because it was assessed by their assessor. And so the important thing to understand is where those boundaries are drawn between your responsibilities and theirs, which is why service providers are required as part of their assessment to have a responsibility matrix. So there's two main things you need from any service provider as an entity that is going through your own assessment, be it a merchant or another service provider using a different service provider. And that is the Attestation of Compliance, which is the official document that says service provider is compliant. But frankly, more importantly, arguably, well, if they're not compliant, then you've got a problem, of course, but very important and often overlooked is the responsibility matrix. This is what denotes the specific requirements that are either met by AWS or there's a shared responsibility between AWS and the entity using AWS, or then are finally fully the responsibility of the entity in AWS. AWS did a great job this year in particular of expanding the detail in their responsibility matrix. They just went through their annual compliance assessment, and that new responsibility matrix has quite a bit more detail. It was quite good last year, frankly, and ahead of many other service providers, but they enhanced even more to be very clear in the level of detail that it breaks down between responsibilities, particularly in the shared ones. Stuart, I'm sure you could attest to the fact that we see a lot of really poorly denoted responsibility matrix.
Yeah, as prescriptive as the PCI Security Standards Council is with all of the other reporting that we have to do. The ROCs, for example, and most of you have probably seen or had a ROC before, it's a very specific format. Everybody knows what to expect and what to look for. There's only a recommended format for the responsibility matrix, and so what that means is that every vendor you work with that supplies one, or every service provider, they're all going to look different. And like Adam said, the AWS version I would hold up almost as a model. It's detailed, and it will clearly spell out for you what they handle, what you need to handle as far as your compliance is concerned. And that, of course, is one of the primary benefits of using a service provider, and especially a cloud service provider in the first place, right? You guys are looking to outsource some of that responsibility for compliance, management, infrastructure, all that kind of stuff. And these two documents right here, which as a customer with an NDA enforced with AWS, you can request to this support portal, are the artifacts and the specific provide those benefits to you. You know, these are the things that Amazon does. These are the things they've already taken care of for you. And as a QSA, when I get those from a customer with a service provider and the AOC demonstrates what they're compliant for and the responsibility matrix is well laid out, it makes things much, much easier for me and my customers when we're doing their assessment, because we have a lot clearer idea of exactly where those lines are drawn.
That's right. It could be a real challenge to have to infer when there is shared responsibility is denoted in a responsibility matrix, but without really any explanation of what part of it is shared. We have to use our best judgment as assessors and work with our clients to understand that, but sometimes it's not really so black and white, and that could certainly be a challenge. I think Amazon did a great job in helping to address that. So just to reiterate, though, what we've been talking about here is it's really important to understand that responsibility for PCI compliance is shared amongst the users of AWS and AWS themselves. As they say, there is the difference between security and compliance of the cloud versus security and compliance in the cloud. Really, the simplest way to think about it is, of course, of the cloud is what Amazon is responsible for. Their infrastructure is compliant and secure and is extremely heavily audited and reviewed by every regulatory standard under the sun, many international standards, country-specific ones that most people are probably not even familiar with. They are just under constant audit, so it's a very robustly secured infrastructure, but that doesn't mitigate your responsibilities of making sure you have applied security best practices and aligned with regulatory compliance controls for your infrastructure in the cloud. And so that's what we're denoting here with this particular graphic.
That's exactly right, and you know, like Adam said, this is all about just delineating the fact that AWS is responsible for the security and the compliance of the infrastructure itself. You're responsible for the security and compliance of the things you use the infrastructure and those services for. And again, this is another thing that's true for any service provider, not just AWS, right? They're responsible for the services they provide. You're responsible for what you do with it.
Well said. Okay, so let's step through here the different top-level DSS requirements, of which there are 12, as well as some of the appendices that have some applicability to AWS in the DSS standard itself, to understand some of the services that support PCI compliance and how they can be leveraged. So, Jordan, this first one here is, requirement 1 is, of course, having a firewall configuration. This is the network security requirement, if you will.
So this just has to do with everybody's favorite PCI scoping topic, which is segmentation, right? This is where you define your cardholder data environment, you define your in-scope systems, and where those boundaries lay. AWS provides services within their cloud infrastructure that can help you do that. The most important of which is probably the virtual private cloud concept. These are isolated private networks that you control and populate with resources within the cloud. They're private networks, they're isolated just like you would do with well, kind of like you would do with VLANs on site. But you can use those, really leverage those in the cloud to create those networks and keep them separate from each other. VPCs, address spaces, you control what routes where, but they don't overlap within the cloud. In other words, you can have 2 VPCs in your account that use the same IP address space if you want to, and the system will not commingle the data. It will keep everything separate just as you'd expect it to if you were using, like I said, VLANs on site or something like that. Second to those is security groups. These are stateful firewall services built into AWS. One of the really interesting things about security groups and how they work is that they are instance or sort of guest host based, right? So you can identify within a security group a specific list of individual hosts, and you can control access to those hosts down to the port, protocol, and service level, regardless of where the hosts themselves actually live, which is kind of cool. In other words, you can create security groups, one that controls access to SQL servers, for example, and you can associate it with all of the SQL servers within your VPC without necessarily needing to care, what their addresses are, necessarily how the traffic gets to them. Network ACLs are more traditional style networking. They control access into and out of a VPC itself. They're not stateful, however, so just like in the old days when you used to have to create firewall rules in both directions, you got to do that with network ACLs too if you want those. Some other things you can do within AWS to help define those borders and that segmentation is there's lots of third-party Amazon machine images out there. So within AWS is the AWS Marketplace. So solution providers put pre-built AMIs out there, which is the AMI is the Amazon machine image, sort of the underlying template that instances are based off of. And they come from all the usual suspects. We've got some out there that are pre-hardened, which we'll talk about a little bit later. Most of the security vendors you guys are familiar with already, so Palo Alto, FortiGate, SonicWall, they've all got AMIs out there too. So if you want to use their traditional technologies and you're familiar with them, go find them in the marketplace, stand them up within your account, and use them and manage them just like you're used to. One of the interesting notes to consider with that, though, has to do with scalability and automation. So one of the biggest advantages of moving to the cloud, especially places like AWS, is the fact that your environment can very quickly and very easily grow to meet the demand of the workloads you're running in the environment, the number of customers you expect, the number of web traffic, the resources you need. A lot of the traditional security technologies you might be used to, like some of those on-prem firewalls, don't necessarily scale as dynamically as a cloud environment can. So it's something to consider in your designs, and we'll talk a little bit more about this later, but as you're building stuff out in the cloud, leverage the services that are there and designed to work with that environment. Security groups, like I said, they're stateful firewalls. You can associate them with specific instances based on the services that they run. You can use firewalls on the individual hosts, sort of that decentralized approach to security, which you can build them into the instances, so as your environment grows, you know that they're already there. There are ways to centrally manage them, but these are things to consider as you're building out. What's your primary focus? Do you want to just outsource the infrastructure and its resources management, or do you have a platform and application that's mature enough or requires this sort of dynamic flexibility that you can get in a cloud environment that's harder to do on site. So those are some considerations related to building the secure network and dealing with segmentation for PCI.
The only thing I would really add here, and Jordan, let me know what you think, but in my experience, this particular aspect of Amazon Web Services, the security groups, how those can be used to provide segmentation and implement network level access control, as well as how those are related to the VPCs and network ACLs, is probably the most commonly misunderstood aspect of the cloud technologies. We see it with our clients, and probably more troubling, we hear it a lot from our clients and other peers of ours in the community with other QSAs or audit firms maybe are not quite as well versed on Amazon Web Service technologies.
Yeah,
so,
I would definitely agree. I think there's a lot of, we joke about this all the time with clients related to even other projects. Everybody in IT gets used to the fact that there's nomenclature and acronym collisions, right? The idea that two different groups use the same terms for different things, and it introduces some confusion and complexity sometimes. In this case, that's certainly true. Folks that aren't familiar with cloud environments and familiar especially with AWS see security groups, and they associate it more with traditional kind of access control lists and access control entry items for controlling, security principal access to a resource. In this case, they work a lot like that, but they're really focused on its network level stateful layer 3 firewalling, right? So port protocols, just like you're used to doing with traditional firewalls on site, but it's applied to the resources you've got within AWS.
Yeah, that's right. So let's move on here. We do quite a bit of content to go through, as I mentioned, but you're welcome to follow up with us with questions, and those that we can't discuss at the end, if we run out of time, we'll follow up with you offline. But to the point of people not necessarily understanding the technologies, that was really the whole intent of the workbook that Amazon had us publish, or Amazon published for us, which is really to educate the community at large there on these technologies. So, so the next requirement here, this is effectively the host hardening requirement for PCI.
Right, and
so
you can. So we talked about AMIs before. You can actually build your own AMIs. So you can start with one in the marketplace. You can import templates. There's a process for that. So you can.
And an AMI, just if I could interject briefly here, for those of you not familiar with the term, is effectively a virtual machine in Amazon Web Services, right? These are the templates that Jordan was referring to. So you can buy virtual images of firewall technologies, and then, of course, the actual server themselves are AMIs.
Yeah, one of the interesting underlying aspects of AWS versus traditional virtualization is they're very service focused. So everything is a service you're deploying, whether it's an instance as a guest OS, virtual machine, container, or otherwise, hosted databases, whatever. They're all services. AMIs are, like you said, they're the templates, the underlying image that those running instances, the actual systems you use to do stuff are based from. So to meet requirement 2, you can create your own. You can use pre-hardened ones like the ones that Anitian provides, I mentioned earlier. But you can create a known good template that you can deploy all of your stuff from, so that if you've got the hardening in place that you need to meet your PCI requirements, you can be sure that it's going to be there for all the ones that you stand up. And in fact, AWS provides a very easy way to demonstrate that, because every instance within the console has a reference to the AMI it came from. So you can show that this AMI is secured appropriately, and all of these running instances are based off of it, which is something that a QSA that understands AWS really appreciates, because it's the easiest way to show that all of the hosts that you're really running really are based off the security permissions or the security settings that you expect to be there.
That's right. And you could, I was going to say, you could couple that with config to validate that there haven't been changes made to that running instance from the base image to extend that principle even further from an audit perspective as far as sample selection and such.
Sure, and we'll come back to config a little bit later. The only caveat to that is that AWS config, which is a really handy way for tracking change throughout an AWS account and environment, won't show you what happens within the VM. It'll show you what happens to the infrastructure and the environment as a whole. In other words, we're instances spun up from different templates? Has somebody else been accessing the templates or spinning them up or down? But it won't show you what's happening inside the virtual machine, so like your Windows policy settings or your Linux security defaults, any of that kind of stuff. So
no, that's right, for sure.
Yeah. And one last point to mention here that it's kind of important and worth noting is that with requirement 2, you're supposed to make sure that you change vendor supplied defaults, especially credentials within systems. Well, any of the Amazon supplied AMIs, so all of the base operating systems, none of those have default credentials. Every time you spin one up, it gets a unique root or administrator password or whatever the administrative account is. However, if you do use third-party AMIs, they may have defaults set. So don't get used to spinning one up and expecting that to be taken care of already. You might have to go back and change it accordingly.
So the only thing I'll add here before we move on is, as we cited here, we do have pre-hardened AMIs of all of the operating systems that are supported by AWS. We have a base server instance version as well as a web server version of each of the different operating systems. And what they also include on those actual file systems of those AMIs is a security configuration standard document that is aligned. It documents all of the steps that were made to harden those systems, as well as has a structure to support documenting the other PCI controls that would be required at the host-based level that would be a responsibility. So it's a real useful tool that you may want to take a look at to address compliance as well as security all in one shot. So the next piece here, this is a big one from a potential impact, of course. This is protecting stored cardholder data, and so Jordan, there's quite a few services here that can be used.
So one of the first and most obvious that we'll point out is the Elastic Block Store. So this is sort of the underlying storage layer for instances and a lot of the services that are in AWS. Discussion of technically how it works is outside the scope of this, but one of the really slick things about it is volumes created within the Elastic Block Store can be encrypted. It is worth noting, just like it says down there under other strategies and considerations, that access to the contents of those volumes is not independent of the operating systems running in your instances, which is a long way of saying that it by default won't meet PCI compliance, but it does provide a way of protecting your data at rest. S3, which is Amazon's unlimited data store for basically anything that you want to store somewhere, archive somewhere. Those also support, you can encrypt the buckets that you dump your data into, and bucket is the technical term for an area of storage within S3. KMS, the actual encryption keys used for both EBS, S3, and pretty much everything within AWS that supports encryption, including hosted databases, which is the relational database service I'll talk about in just a sec, can leverage Amazon's key management service for actually managing the encryption keys. And one of the nice things about that is managing the keys rotation year in, year out, going in there and having somebody, decrypt, find a new key, recrypt, all that kind of stuff is managed with a checkbox. You create the keys in KMS, you associate them with the resources that need to use them, and then you check the key rotation box and it's taken care of for you. It's the simplest key management system and security module that I've probably ever worked with.
Yeah, it's really slick, and it's a great example of how the abstraction of these back-end technologies really simplifies the ability to implement security controls in many cases. I think RDS is another great example of that, where the idea is, rather than having to spin up a AMI server instance and then install your database platform on it and manage both the OS and the database, Amazon just publishes a service where you have a database interface, but you don't have any visibility or responsibility for the underlying operating system.
Right. All you care about is what data you put into it and managing access to that data. They take care of the operating system, the database engine itself. They do updates. They do software management, security of the underlying database itself. All of that's handled for you. It's just a resource, just another service that you can spin up within AWS. Right now they support Oracle, Microsoft SQL Server, MySQL, and Postgres, I believe, are the 4 types that they support. All relational database systems also support underlying data encryption using a KMS key for actually encrypting the volume. They also support high availability and redundancy sort of out of the box, which is really kind of nice. And since the database volume encryption for RDS is controlled by Amazon and by RDS on the back end, it is independent of the operating systems, and so that actually can meet PCI compliance. The last thing to note here is that if none of those, if RDS doesn't work for you as a database solution, you want to use something else, you want to set up an own instance running, maybe a NoSQL database or something like that, you can set up an instance and install a database just like usual, with the caveat that if it stores in a CHD, you'll have to manage its encryption. So whether or not you want to use TDE or field level encryption or throw a tokenizer or something in front of it, just like you would with an on-premise solution, you can do that in AWS. It's just one consideration to think about.
Yep, but RDS is really quintessential, better, faster, cheaper example of database management. So I highly encourage you to leverage that if you can. So the next requirement here is requirement 3 is data at rest. Requirement 4 is data in transit encryption.
And I would have to say that this is one of the areas where we get a lot of, to your point before, Adam, we get a lot of questions from customers and a lot of misunderstanding about how stuff works in AWS. VPCs and your environment within AWS is a private network. So you don't necessarily need to worry about encrypting the data going, between your instances within a VPC. Only stuff that leaves the VPC for the internet is what you got to worry about there. A lot of these services are based around preventing transmission of any data from going across a public network without being encrypted. So elastic load balancers, which we'll talk a little bit more later, but network ACL, security groups, those are all things you can do to ensure that only the ports and protocols that you know are secure are in use or even reachable. One of the nice things about elastic load balancers is they can not only load balance incoming connections, but you can use them to abstract hosts behind the load balancer and ensure that the only inbound connection of those hosts are on secured across secured channels. Have the load balancer only support incoming TLS connections, for example, even if the backend system can't for some reason. The elastic load balancer can act as an endpoint. One caveat about that is elastic load balancers exist outside your AWS account, which means the connection from them to your backend environment still should be encrypted, even if the backend system needs to support an unencrypted connection for application access, database access, or whatever else. Other option you have here have to do with customer gateways, virtual private gateways, VPN connections, and AWS Direct Connect. So the first 3 of those is designed for creating a typical IPsec-based business-to-business connection from your Amazon VPC to your on-premise environment or to another on-premise environment. You can even use it to create connections between VPCs if you want to. There's another way to do that we'll discuss when we get to the reference architectures, but that's a typical IPsec tunnel like you're used to doing with any other business partner. It meets the requirements for security in transit. It follows industry accepted best practices. Setting them up is very, very simple, probably easier than dealing with a lot of other customers from within Amazon or within AWS. When you want to set up the connection, you tell it what kind of VPN concentrator endpoint you're going to connect to, and it generates the config for you. Direct Connect is a dedicated back-end private circuit between Amazon, between your VPC and your on-premise environment. So think MPLS connections like you might do with other business partners where you don't want to transmit data across the internet. You want to go direct from party to party. That's supported via Direct Connect. Other strategies.
The only thing I would add there, Jordan, is that you just need to be very cognizant of when you're doing some of these technologies that allow you to connect your VPC to your on-prem networks or some other network that's going to have impacts on your scoping of your PCI assessment. And we'll talk about that more in the reference architecture review.
Right. But the really handy thing about it is if you're connecting, like you can build a VPN tunnel between CDEs, for example, just like you would do with on-premise scenarios. Let's say you've got multiple sites where you've got, maybe a retail store and a back-end store or whatever, and you can create the IPsec tunnel to isolate that CDE traffic. Well, you can do that with VPCs in AWS also, just like you would on-site, in fact, and it functions the same way, where you can be sure that it's a trusted private network connection, not have to worry about it. The one thing I want to mention related to other strategies and considerations real quick has to do with a specific AWS service called Certificate Manager. One of the really handy things about AWS, especially if you're running elastic load balancing, using CloudFront, and some of the other services in there, is that you can actually leverage this service to manage your TLS certificates for you. So they'll deal with certificate renewal, exchange, all that kind of stuff, and they generate them using 2048-bit encryption for the certificate itself, and the signature algorithm, I believe, is SHA-2, so it meets all of the usual requirements out there. The only caveat to it is that that service itself is not PCI compliant. So the things you need to do to manage certificates still apply within this environment, as far as making sure that they're current, monitoring them, and so on.
That's right. So the next piece here is the requirement 5 is your antivirus requirement. It's a very focused requirement. The DSS structure is certainly one that folks can opine on, but due to how focused some of the requirements are versus more broad category approach of other top-level requirements. The 5 is very focused, AV only, and the long and short of it here is that AWS doesn't have any type of anti-malware or antivirus service available, so it's your responsibility to install this on any of your instances that you're running yourself. But there are plenty of third-party tools available in the marketplace.
Yeah, and that's really the good news here, is you can use whatever you're familiar with already. If you've got an on-premise solution, you can easily extend it into your AWS environment and use all of the same stuff and all the same policies and everything that you've already got. But you have to do something.
That's right. Okay, so next one here, good example of kind of the divergence in scope of the requirements. Requirement 6 includes vulnerability management, patch management, configuration management, and secure software development.
Yeah. So Amazon doesn't help you with your own policies, procedures, and processes, right? They'll provide you services for that, but they don't handle that stuff on your own, which should be relatively straightforward, I think, from most customers' point of view. They don't offer any services directly targeted at meeting these requirements. However, there's things that can help you meet those requirements. For example, for their own version, their own flavor of Linux that they offer AMIs for, they have a security bulletin list, just like you'd expect from Red Hat or Debian or anybody else. And you can use that to be aware of updates that are out there, what you need to do, and keep on top of patches for your systems. They offer 2 services related to software development and deployment, which is code commit and code deploy. There's another one out there too, that the name escapes me real quick, but this is all related to development process, right? So code commit is a managed Git repository. Code deploy is a software package management system you can use to actually push software within your AWS environment. So if you've got internally developed stuff or you want to be able to package other software deploy, you can use code deploy for that. Code pipeline is the other one, where you can create a managed development build process.
Yeah, and I would also add to that. I'd also add to that whole idea of infrastructure as code is CloudFormation, which allows you to template entire environments.
Whole
which we
application.
see some. That's right. We have some mature AWS clients that all changes to their environment are through CloudFormation scripts in production to really enforce robust change control.
Yeah, without diverting too much from PCI compliance, one of the and we can talk about it more when we get down to the best practices section, but there's some resources within AWS, some classes and documentation and stuff around really applying that ITIL managed software library thing to your environments within the cloud. In fact, that's a specific service that is offered as the managed software library. So there's ways of really moving to the point where you can deploy iterations and versions of your application environments to keep them up to date in a managed and controlled fashion, including separation of duties and all of the other checks and balances that you need to put in place. That's outside the scope of PCI, but it's definitely worth looking into if you're going to head down the AWS and the cloud service route. So lastly, related to development and secure, there's third-party management APIs to help you do phone scanning and code scanning and all that kind of stuff, system testing. There's also the use of the Amazon WAF and Amazon CloudFront. So CloudFront is their content delivery network. It's for website acceleration, website content delivery, that kind of stuff. And in front of CloudFront is an AWS managed web application firewall. This is great because with a web application firewall in front of your application, you don't have to do the same security manual security and web application testing that PCI requires. The WAF only works with CloudFront at this point, though, so your web application would need to be support, or you need to put CloudFront in front of it. The good news is their WAF is it scales with CloudFront really, really well, and it supports most of the main features you'd expect to from other WAFs, as far as you can create ACLs that will allow or block communication based on where it came from, the properties of the request header, text strings within the header. Does it contain known malicious potential SQL queries, that kind of stuff. You can do all of that with Amazon WAF.
Yeah, and that's a really great feature of it, because in the context of PCI, requirement 6.6 requires either annual web application security testing by a qualified third party, or have a web application firewall in front of your public-facing web apps in your assessment scope. However, I always strongly encourage anyone who is going the WAF route to meet that requirement, that they still have web application security testing performed to make sure that there is not a unknown vulnerability in the web application, because if there is, it's not, for WAFs to be effectively deployed and really protect your application, you want to tune them to any known issues. And so the Amazon WAF does give you that ability, such that if you perform a test and find out, let's say you've got reflective cross-site scripting pervasive throughout your application, and the remediation cycle is going to take a while, you could explicitly tune the WAF to block those specific vulnerabilities that are unique to your web application instance while you buy yourself time to remediate. And so you're now achieving both compliance and security and risk reduction through that approach. One other thing I would add here, we talked, I just want to reiterate that, Amazon Linux, the security bulletins, they let you know when new patches are available. They do not patch your AMIs for you. That's your responsibility, be it using Amazon Linux or any of the other Linux distros or Windows instances that you might be running in your VPC. And Jordan, you touched on the different third-party tools that are available for vulnerability management. Amazon does have a tool that is still emerging, so I think it shows promise. It's not there yet fully, but it's worth keeping an eye on, called Inspector, that does some security configuration review of your VPC environment in your EC2 console. We like Nessus for that. They have a plugin that is much more robust, specific to AWS, that will identify vulnerabilities with how you've configured your EC2 console itself, which is how you manage your cloud environment, independent of actually the underlying servers instances that you'd be running.
Well, and we're getting a little bit into requirement 11 there, but I think the important point for this here is that running instances are just like any other server that you're familiar with. You have to maintain them, update, and keep them up to date. The AMIs they were based off of can be updated and newly generated, but it doesn't necessarily mean that those changes apply automatically to the instance that was launched from the AMI.
That's right. That's right. Okay, so let's see. The next requirement here, 7 and 8, to me, are really companion requirements, which are effectively identity and access management. The 7 is more access management, and I guess 8 is more identity management. But
well, the important point really to cover here is that there's a service within AWS called IAM, which is Identity and Access Management, as you would expect. It controls access to AWS itself, the resources you build in there, your instance, your RDS databases, your security groups, your S3 buckets, all that stuff. That can't be used for applications, it's just for AWS. Although you can stand up, there's a directory services supported within AWS that you can use as a traditional IAM solution, whether they support a hosted Microsoft Active Directory, they have a Samba-based instance, but you can point your applications and IAM at that for your centralized user repository. If we go on to the next slide.
Yeah, and I would just say, we'll go into 8 because these tie in together, and specifically what I was going to say there is what it really means is that you're going to have to potentially manage 2 different identity access management stacks at your instance level and at your EC2 level. And a lot of times we see when we're looking at some of the security requirements around identity management, such as password complexity and rotation and these other things, people might have applied them within their server instances, but they forgot to enable those for IAM, so that which is, of course, you need to do because that's really the key to the kingdom. IAM controls how you would authenticate to the EC2 console to manage all of your resources.
Now, IAM itself supports a lot of the password requirements you needed, but not all of them. As we call out here, there's some limitations. It doesn't support lockouts for invalid logon attempts, it doesn't support lockout durations, and it doesn't support idle session timeouts outside the fact that it's a web application itself, but it's not something that you can configure to meet the requirements. It does support an AD connector, though. If you have an on-premise or even your own managed AD environment within AWS, IAM can leverage that for the identity and access management that you need to be compliant. So those are important things to note. Additionally, if you set up, if you use the Amazon Directory Services for identity and access management within your applications, those don't support all of the password requirements you need to meet requirement 8 either. Even the managed hosted AD instance doesn't. Primarily, there's some technical reasons for it, but it's enough to know that you as a customer don't have a way of supplying or changing the domain password policy.
Okay. Yeah, that is an important point to be aware of there. But nevertheless, it is definitely some options available for how you can manage identities using the AWS services. So moving on here, requirement 9 is physical security, and there's really no considerations here for AWS if that's what you're using entirely, because it's fully covered. There's no shared responsibility. It's fully covered by their attestation. Of course, if you are doing some type of hybrid deployment where your CDE is connected to on-prem, obviously you're still responsible for the physical security of the non-AWS environment.
Right, and their security, it's worth noting too, their AWS doesn't cover, if you have point of interaction devices or POS terminals, that kind of stuff, those obviously would be outside of AWS and not covered, and that applies to media. If you, export data because you want to back up, your credit card transactions or something, and that's outside AWS, obviously that wouldn't be covered either.
Sure. So requirement 10 here is your logging requirement. Audit log generation and log management, log review. And so AWS has a couple services here that could support those activities.
Yeah, every service within AWS down to the API level support logging of who made what request with what data when, and all of that is supported through the service they call CloudTrail, which essentially means or works by you create an S3 bucket where you want the logs stored, you turn CloudTrail on and point it to the bucket, and all the activity within your AWS account gets logged and recorded there. That data is available to you. You can pull it out. There's SIEM solutions that support and look for that data. But it easily provides all of the audit records and everything that you need right there. The one caveat, so that's within AWS itself, not necessarily the instances and applications you put in there. You still have to find a way to do their logging. You can create S3 buckets to put them in there too, but you'll need something to deal with that, whether it's third-party AMI or whatever is built in your application. The other thing to note is that AWS does not itself include or supply an NTP server or time synchronization for your instances. So that's something you'll need to set up, whether you point them at it, pool at ntp.org or set up your own instance within there, whatever, that's something you need to do.
Yeah, that's right. The next requirement here is another bit of a grab bag of sub-requirements. AWS does address some of requirement 11. Basically, you've got wireless security scanning for rogue wireless access points. That's fully covered by their AOC for their data centers. You'll obviously don't even have access to those or even know where they are other than the region that they're in. Then there's vulnerability scanning is the next component of that, which is your responsibility for your instances. Then is
Well, and I think that's kind of the important point is all of their infrastructure, they get tested every year. The stuff that you put in the cloud, just like we talked about at the beginning related to that shared responsibility model, you're responsible for scanning and testing in order to meet your PCI requirements. The really important thing to pull from this slide is that if you're going to do security testing, especially external against your environment, you need to coordinate with AWS support. They've got a really good, as you can imagine, security monitoring system and response system in place. And if you have your vendors start scanning your environment in AWS without letting them know first, they're going to blacklist you or blacklist your security, whatever company you're having do that scanning, and they'll never be able to hit any AWS stuff again after that. So as you can imagine, that's a pretty important thing. It's an easy process to do. From within your account, you can go to the support page and submit the request right there. There's a predetermined form for it, and what they're really going to want to know is which resources are you going to hit for your testing, and when are you going to do the testing. Wait till you get their approval so that they know that it's happening before you start.
And they're really responsive with the approval requests.
Yeah.
So vuln scanning and pen testing, you're responsible for your assets. Not theirs are covered by their AOC. Same with the wireless access point detection. The last two components of requirement 11 are intrusion prevention and file integrity monitoring. They do not offer solutions for those, so that is something that is your responsibility there. We see a lot of people using either standalone in marketplace third-party products for network IPS or
host-based IPS or something, sure.
Sometimes we see some host-based IPS for sure, yep. And then for FIM, you're on your own there as well at the server level. Requirement 12 is the policy and procedure component of PCI, and there's nothing here that is covered as far as the policies and procedures you need to implement for your environment. Obviously, they have them all to manage their environment that's covered by their audit. So we're going to talk briefly about some of the new components of PCI DSS 3.2, the appendices here. The first one is not new. This has existed for quite some time, but it talks about additional PCI requirements for shared hosting providers, which in fact you can be using Amazon Web Services, which themselves are a shared hosting provider.
Yeah, so the typical services we talked before about, network segmentation and host isolation apply here also. It's interesting to note that if you stand up separate instances for customers as a shared hosting provider, it's just like standing up separate VMs on your own site. They're not technically shared hosts. They're hosts dedicated to your customers. But if you have one host and you're doing web virtualization or something like that, you can provide the same kind of isolation and using the network security technologies we talked about before, and that applies to elastic load balancing and stuff outside there too. If you're doing port forwarding or port mapping and that kind of stuff, that should work out to that level too. Oh, and if you're using CloudFront for those kind of stuff, using the WAF where you can create ACLs based on the headers for the requests, that should also support if you're using like host-based or domain-based web application mapping and stuff also.
Good point. So A2 is a new appendix for PCI DSS version 3.2, which is talking about the controls around using SSL or early versions of TLS. There were some updates that were posted to 3.1 via a blog post by the council, and then those were formalized in 3.2 throughout the requirements they apply, and then there's some additional controls around them to formalize that management for the conditions under which you are permitted to use these insecure versions of TLS and SSL, but there's really nothing that is supported by AWS for that.
So the next appendice that was added with 3.2 is they incorporated the designated entities validation or the additional validation for designated entities into the DSS itself. Again, AWS doesn't have a lot that they can help you with directly here, primarily because this is mostly around process and procedure. You have to proactively test your environment and validate your security controls and processes more often than is required of a typical PCI environment, every 6 months for vulnerability testing, every quarter for process and procedure controls, and so on. AWS provides services that can help provide that information for you. You can use config that we talked about before, and CloudTrail as logs to prove that processes or that things, your procedures are being followed the way that they should be and that changes aren't happening that are uncontrolled. CloudWatch is a resource and metric-based alerting system within AWS where you can set rules to help ensure that the environment is behaving predictably. S3, you've got API access to your S3 buckets, so if you're using them for storage, you can actually programmatically scan them and query them and search for certain data types or for cardholder data to assess your discovery processes. And then, of course, in the ensuring logical access and monitoring logical access is provided with the same stuff we mentioned before for requirements 7 and 8. One thing to note here is with access policies in AWS, so when you use IAM and you set it, you create access policies to control access to resources, there are a few services in AWS that support directly attached access policies without going through IAM. S3, in fact, is one of those. So when you're looking for those policies and documenting them as required for DESV, there might be a couple extra places you have to look.
Good point. So yeah, just to kind of clarify what a designated entity is. These are entities that have been designated by the card brands to be effectively systemically important to the payment ecosystem at large. These typically are the very high volume merchants would come to mind. And so effectively these requirements are enhanced, more robust PCI and security program management items. So,
and frankly, if you're a designated entity, you know it because the card brand or your acquiring bank has told you you're a designated entity. So
you have been designated formally,
exactly.
Yes.
So the important point to note there is that even if you're a designated entity, you can still meet your PCI requirements within AWS.
That's right. So let's get into the reference architectures here before we run out of time, because this is an important component of what we wanted to talk about today. Again, these are examples of common topologies that you can deploy in AWS. We have 3 different ones that we're going to walk through here. The first here is the simplest. This is a dedicated environment in a VPC for PCI, so fully standalone.
This is somebody setting up an entire, their PCI environment is, a single application or whatever, all within their account. This is somebody, which we actually see a lot, especially for startups and new businesses, where they're going to build their stuff on AWS and they want the whole thing to be PCI compliant. That's essentially what this represents.
Right. Now, this is simplified, of course, because what you would need to have in here within that management network, you would need to have any of your security technology consoles that you would have to deploy AMI instances of, since, as we discussed, some of these technologies are not provided through web services, Amazon Web Services, for example, such as an AD management console. But the gist of it is that you can very easily, and we've seen many of our clients successfully deploy these fully isolated CDEs in AWS.
Yeah. So within this environment, if we talk a little bit about scope, everything in this environment is in scope for PCI compliance. The internal CDE and DMZ CDEs are the cardholder data environment, of course. The management network is in scope because it obviously affects the security of those, but isn't part of the CDE itself since it doesn't handle any cardholder data. You'll have to create security groups to help isolate those. The workbook has specific examples of what those look like, but this is a fairly typical environment.
That's right. The workbook does have, as I mentioned earlier, screenshots step-by-step to build out these reference architectures. And so we talked about this here. This just explains the basic architecture. So the next one here is our segmented architecture. And the difference here from the last one is that, as you can see, there is now a second VPC of other assets that an entity might be hosting in AWS that is actually out of the assessment scope entirely, right? There's basically 3 classes of networks or network segments that are in consideration for PCI. They are the networks that have cardholder data. That's your cardholder data environment. Then there are the networks that are in the assessment scope by virtue of being connected to the CDE. So these are generally your management networks, or they may have end users, for example, in a more traditional environment. And then finally, there's the out-of-scope networks that exist in a traditional on-prem solution, or in this case here as a separate VPC.
Yeah, and I'd have to say this is probably the most common scenario that I see in AWS because most folks want to leverage a cloud infrastructure, all of its benefits for their PCI environment, but not just for PCI. So what this demonstrates is that when you create separate VPCs, they're isolated, logically separate networks within your AWS account. There's no traffic between them. In fact, like you see here, they both have their own internet gateway for getting outside of their own network. So you can be sure that the data or the systems within the out-of-scope VPC there's no connectivity between them and any of the in-scope systems at all. They're separate private networks within your AWS account.
That's right. I see them for just additional services of the entities that they're hosting in AWS that have nothing to do with cardholder data, or a lot of times development environments for pre-prod type of testing or UAT.
Right.
So this just describes as the gist of the architecture here.
And
so let's move on to the next one.
Yeah, so this is a connected environment. This is a much more complicated solution, but this is the idea to show that you can actually extend an existing on-premise network into the cloud using typical business-to-business VPN tunnels or direct connections like you would with traditional data centers or business partners or whatever. On-premise, you can have systems that are in scope and out of scope and isolated by firewalls, routers, and your other segmentation technologies. And you can do the same thing in AWS. You can create VPCs that are connected via a VPC peering, which is like a layer 3 bridge that you can build between VPCs. You can connect them with tunnels, or you don't have to connect them at all and still maintain the segmentation you need within the cloud environment. So going through this is like I said, it's the most complicated connection, but it's demonstrate the idea that if you want to just extend existing stuff or replicate to a certain degree the kind of system that you've already done on site, you can extend that into the cloud very, very simply and using same things that you already are familiar with. One of the advantages of this kind of scenario is if you have on-premise management technologies already, whether they're security monitoring, antivirus, security management, IAM, all that kind of stuff, building the connection between your compliant cloud environment and your on-premise stuff allows you to leverage those exact systems within the cloud.
That's right. Of course, because by doing so, you're bringing them in scope if they were not already in your scope previously. And so, of course, the PCI controls need to be applied to those systems.
Right.
So, if we can briefly talk a bit more about the third-party solutions that are available in AWS before we address any questions that we have time for. And again, we'll follow up offline with any questions that people have submitted that we didn't get a chance to discuss here in the brief time we have left today. The first are the pre-built AMIs. As we said, many of the common vendors you can see have these available in AWS. So you buy the image, you can see how it's priced based on utilization, just like everything else in AWS. So very streamlined and easy to deploy.
Yeah, and as you can see here, they're predictable vendors. They're not folks you haven't heard of before. They're the folks, the names that you know and trust, and technologies that you know and trust. Everybody has versions of their on-premise solutions in the cloud. And to be honest, I have yet to find a company that you work with on-premise and are familiar with that doesn't have something that will work within AWS.
That's right. And so these are just some of the services gaps that AWS doesn't provide that are PCI requirements, as we touched on as we walked through the standard earlier, that we would commonly see third-party solutions deployed for. Putting in IDS, having a log management solution, patch management, vulnerability management, file integrity monitoring, et cetera, or enhancing some existing AWS services.
Yeah, so AWS supports its own IPsec, VPN solution, for example. But if you've got an on-premise technology that has compatibility issues, and I'm talking about WatchGuard here, for example, you can actually stand one of those up in the cloud and establish the tunnels in a way that will work there. There's also solutions that support automation and management of AWS itself that sort of help make this process easier for you to manage. Like Adam mentioned earlier about CloudFormation templates and that kind of stuff. That's built into AWS, but there's third parties that can help you deal with those and monitor their compliance, configuration, and so on.
Yeah, Terraform, for example, comes to mind. So
yeah.
A little bit just here briefly about best practices within AWS before we're out of time, is to, again, make sure that you got to get the compliance documentation. They are compliant. That's a non-issue, but you still need to have that formal documentation that is only available on request after signing an NDA with Amazon. And again, the important part is understanding that responsibility matrix, which has really improved this year. It is probably the best in the business right now, from my perspective. And making sure you're understanding these technologies and documenting how you have configured them.
So there's a couple things here real quick that I want to touch on related to the documentation. Is all the resources you create in AWS, you can assign arbitrary tags to. So you can easily identify and group all of your PCI related stuff in one place together so you can look at them quickly and easily. There's also this Trusted Advisor service, which is something that will quickly tell you if some of the best practice configuration stuff for your AWS account has been taken care of or not. For example, changing the root account password and enabling multi-factor authentication with root account password. It'll and for free built in tell you real quick if there's a couple things you need to take care of off the top or right off the bat.
So technical configurations, we're about out of time here, but it really makes the whole endeavor much easier if you can establish naming conventions and understand how you are going to structure your environment. Using our reference architecture is a great start. Having your encryption keys made, you need to do that right up front. Putting your monitoring in place.
Create it ahead of time. Absolutely.
That's right. Use ELB if you can, and understand your architectures so that you can support dynamic environments. Preparing for the audit is, the more prepared you are, the better your audit is going to go. Make sure your QSA understands these technologies. Make sure you have all the things that you would normally need for PCI as they apply to AWS prepared in advance, so you could demonstrate competency to your QSA. And so we're about out of time here. I only have time to answer one question, but we'll follow up with any additional questions you submit, or the ones we don't have time to discuss here, which is really about PCI DSS 3.2 itself. That is, what is the most impactful new requirement that came out in the standard? And from my opinion, there's a new requirement for multi-factor authentication that is required for any administrative access to the cardholder data environment. It used to only require multi-factor authentication, or two factors, it was commonly called historically, for remote access coming in over the VPN into the CDE, right, across the internet. Now they require it for any administrative access to the CDE. It doesn't have to be at the server level or the system level. It could be at the perimeter level. IAM does support multi-factor authentication, but you'll need something, since there's not an SSL VPN solution, you'll need something for access to your instances themselves, either deploying a virtual SSL VPN that supports multi-factor, or if you're doing it, let's say, with SSH to servers directly through RSA keys or something to that effect. That requirement is forward dated, though, until January 31st of 2018, so you have some time to put that in place. So we ran out of time. I appreciate everybody's attendance here. We'd be happy to follow up with any questions people might have as a result of this. The presentation will be available on our website, and thanks again for attending.